we present a collection of tools for building plug-and-play modular physical computing systems that we call Modular-Things. We will briefly introduce 3 issues with the state of cyber-physical prototyping, describe our approach to creating interactive, extensible physical computing systems, and demonstrate some applications of Modular-Things to prototype machines. Currently, the most accessible way to develop cyber-physical systems are with platforms like Arduino, which allow users to write portable embedded code. We seek to address 3 main issues with this single microcontroller compiled firmware approach. First, compiling and flashing firmware prevents interactive development. Second, single microcontrollers create monolithic systems coupled across design, mechanical, electrical, and software layers. And third, single microcontrollers run out of physical resources, such as GPIO pins are all occupied, or I2C address collisions occur. One approach to improving developer experience with microcontrollers is to embed high-level languages into devices. We propose, instead of trying to put high-level programming into devices, we lift devices into high-level programming environments by way of virtualization. Here you see a minimal demonstration of our system. As devices are plugged into the computer, they are automatically enumerated and show up in our web-based editor. Notice that the API for each device is also described. Users can use JavaScript to integrate device functionality into cohesive systems. Watch as a few lines of JavaScript code allow us to create a potentiometer-driven servo motor. With a few more lines of HTML and CSS, we can create an interface for our system, capable of driving outputs or receiving inputs from our physical devices. We created a set of single-purpose embedded devices. But more importantly, we developed a method to making extensible hardware systems with interactive development tools. This method consists of a link layer agnostic message passing system for communication between devices, and a web-based programming environment. Here you see a self-playing xylophone developed with Modular-Things. The machine can be driven from a web-based sequencer created with HTML, JavaScript, and CSS. We tested Modular-Things in a classroom setting, where groups of novice machine builders constructed custom machines that integrated embedded system modules with high-level responsive interfaces. In the future, we plan to develop a wider variety of link layers and methods to allow Modular-Things to operate independently of the high-level computing environments in which they are developed and configured. Thank you for your interest, and we welcome your participation in the project. Everything presented here is open source and available on our GitHub.